Hey, this is Passy from Passy's World of ICT, the guy with the white hat. And today we're having a look at testing. So it's not programming. Some people might find this a bit boring, but testing is like a really essential part of the software development process. And it's been a bit disappointing with our students doing assignments that, a component of it is the testing and they kind of leave it till last. They rush it. They don't bother doing it properly, and they're not scoring as high on their assignments. So we've made this video all about testing, which covers a lot of things, and we better get started so it's not outrageously long. So I'm going to be looking at formula and functional testing, module testing, unit testing, systems testing, integration testing, and acceptance testing, which is kind of like your full development life cycle testing that you need to do, and how you set up a test table layout to put what tests you're doing and what the results are, and have that like in a Word document or something as part of testing documentation that you hand in as part of your project. And yeah, we do this in the real world in programming as well. So a component is any piece of hardware or software so that you might need to test. So it's also hardware, not just the software, and both things need to be tested, all right? So hardware testing for systems are, things like printers and scanners are going to hook up to your system. They need to be tested under working conditions. So like they have these test station things and they plug them in and make sure they're all working and things like that. If this is a little bit too fast, there is a free download of this presentation. It's free, and that's in the video description. So we're going to try to do this pretty quickly. You can probably then just, get the PDF download and read through it yourself. So there's module testing, integration testing, systems testing, and acceptance testing, and you basically do them in that order. And so you want to try and break the application, make sure it's bulletproof, and it's going to be good when people finally get it to be used in the real world. So Visual Basic is an object-oriented language. So there's all these objects like text boxes, buttons, labels that we can drag out onto the form, and they're all set up ready to go. You don't have to write the code to produce them on the screen, which is, oh my goodness, what we used to have to do back in the dark ages when I was doing programming, and that was an awful job doing screen layouts and coding. But now it's all done for you with Visual Basic, the best learning programming language. So module testing, you look at individual parts of your program, like the sub-modules, the subroutines, those private sub, public sub things in Visual Basic, those little tiny blocks. So you just sort of develop them and test them one at a time. And you've noticed that's how we do our programs. It does take a long time to do them when we're doing the videos, because we say, okay, here's version 1. We're just going to get it set up to just do this basic thing, and we're going to test it and make sure it's working before we go to version 2 and add something else in, like more subroutines, and then we test them. So we build up the subroutines kind of one by one and test them as we go, and that's the best way to do your programming and your testing. All right, once you've got all those modules together, then it's time to do integration testing to make sure the whole thing works together. So you've got your top level module that's calling other ones. You need to make sure it does things like load up a combo box from an input file. That works okay. Make sure the thing can read your input file and get some data into the program, and maybe it loads that up into an array, as we've seen in previous lessons we've done. Make sure the validation submodule is checking out that all the fields that they're entering on the screen, that they've actually entered them all. They've picked and clicked things that they needed to do, and the right type of data is in those fields. And then test the calculation module that will take all the things they've put in and assemble that into information and put output onto the screen. So this is your integration testing. So there's a little bit of a Python program we did earlier in our course. So you can see it's worked out this sumo cost in dollars here in the calculation submodule. So we get that working, and then that can flow down into the comparison module where it's comparing that cost in dollars with other costs in dollars against other companies and things like that. So you know, this is sort of the integration testing where you test where all those modules are doing the right thing and talking to each other and passing the data to them, and we get the right sort of output out at the end of the program. Then once we have quite a few programs that we're linking together to make like a little system, which we haven't done in our course yet, but we will be doing later on. So you'll have like a program for the logging in that shows like a user ID and they can put their password in, and we'll check that out against a file to see if they're legit and whether we're going to let them into the system. Once they're into the system, there'll be several sort of screens they jump to do different functions and things they need to do. So that's systems testing. So once you've got your entire system, you put together some dummy data. So you might not have the real customers on there yet, but you kind of have some customers made up, have some sort of data made up about items relating to that system, data that's going to be coming into the system and all that sort of thing, or sort of little test scripts of data which needs to be typed onto screens and stuff like that. And in the real world, yeah, they even have these automated things now which kind of people used to have to like get on the screen, look at some test script and go, oh, I've got to type this stuff in now and check out how that works. Well, they've got kind of robots that do all that, and then screen scrapers that sort of capture all the results straight off the screen. So a lot of that's been automated with AI now, which kind of makes testing a bit less boring, because it used to be boring sitting there doing scripts. I did that for a little while and drove me nuts. Okay, enough on that. And the final step's acceptance testing. So this is kind of the most important test that everything has to pass. We've been through all our testing stages shown here in the top right-hand side. So we were doing our coding, unit testing, you know, testing each of our modules out. Then once we had a fully working program or a couple of programs, we'd integration tests to see that they all work together and the design's happening okay. Then you do your system test where you've got the whole thing running together, and you check out whether all those original functional requirements that were written up in the design spec, that the system can actually do all of those things and do them properly. And the last step is this acceptance testing where you sit down with the client or a group of people from the client's company, and they all kind of check out the system and try it out, and then if they're happy with everything, it's doing the right job, they'll do the final sign off and you get your final payment, which is good. So the whole job's finished. Hopefully they really love it. They tell other people about it, and you get some more work. Just a little cartoon there to amuse you. User requirements, 400 features. Oh my goodness. Yeah, good point. Better add easy to use to the list. Yeah, right. That's typical management versus programmer type sort of thinking and logic there. And I've encountered that in the real world, and it's not good fun. All right, so let's go to the next section now of our presentation, which is setting up the test data. So you've got to cover all these conditions. This thing called boundary conditions are really important, and we're going to talk about that in the presentation. You know, exception processing when people haven't filled out all the things they needed to, or your file wasn't found and couldn't be read into the program with the data. And then like these Homer Simpson's tests where you just put outrageously ridiculous data in just to see what happens and make sure that doesn't break the system. So when you're getting all this test data and you're just crunching it through the system there, you should try and test every possible code and logic fault you can think of, every type of input that people could type into there, or stuff they could even have coming in a file that's complete garbage, and make sure that doesn't get processed, that it's error trapped and messages are given. Now, the test data modeling should focus on particular parts where they're likely to occur, like especially where you're doing less than, greater than things, which we're going to look at in some examples, and boundary conditions. These are called tipping points, and we're going to talk about these things next. They're extremely important. Tipping points, that you know this, and this sort of stuff is often on exams in computer science. Alrighty, so let's look at this example. This is for under 16 years old. So there's a new airline booking system, and you get discount fares if your child is under the age of 16. So it's no good them being exactly 16, because discount time's over. They're not under 16 anymore. they're exactly 16 and you don't get the discount. Now, I don't know if airlines do this anymore, but when my son, just before he turned 16, we did this big trip to America, which was great because I think his airline fares were only like 60% of the normal fare, but as soon as he turned 16, of course, he'd have to be paying full fares. So what would be the necessary test data to thoroughly check out this system and test it? Well, the answer is you need tipping point values, okay? A bit like that kind of seesaw there. That must be a great piece of wood or whatever it is because it's not snapping in half. But anyway, for under 16 years old, the tipping point or the critical point is 16 years old. Like when my son turned 16, he couldn't get the discount fares anymore. So you've got to make sure you test data immediately either side of that tipping point. So you want to test someone who's 15 years old and make sure they do get the discount. Check someone who's 17 years old, they should not get any discount. And someone who's exactly 16, they should not get a discount either because they have to be under 16 years old for the functionality here. All right, so let's test that out. So the boundary is 16 years old. Now, don't do values like a 4 and 28, right? They're waste of time values because we're going to use 15 and 17, the ones that are really super close, right on either side of that tipping point boundary. Okay, so they're the ones you use. You don't use things like 4 and 28 or 88 and 1 and things like that. You've got to get right next to the tipping value. Now, here's a program written in Python, actually, not Visual Basic. Python's a great language as well. We just don't like it because it's so hard to make our input screens with it. So that's why we use Visual Basic for our educational teaching. But we have taught the students a little bit of Python just so they know what it's about. Now, in this logic here, if the age is bigger than 16, they're up for full fare. If they've turned 16, bad luck, they're paying full fare. So in Python, notice you use these double equals for exactly equals. In Visual Basic, we only use one. And otherwise, if it's not one of these cases, they're not too old, well, then they can get the discount fare, okay? So this logic is good. And when we actually test it and run the program, putting in inputs here, because that's the input statement to get input from these. If we put in 15, they get the discount. That's beautiful. 16, though, they're up for full fare. 17, they're up for full fare. So we've done good tipping boundary tests there. The program has passed the test. That's a big happy tick for that one. All right, let's look at one now where there's a programming mistake in the logic. So remember, they have to be under the age of 16. Now, most of the logical errors you get in programming happen at these tipping point boundaries. And typically, especially in software development here in Melbourne, Australia, they will have exam questions on these types of things. So you've got to find the fault in the algorithm or the code that's being given to you and look out for these sort of less than, greater than areas of the program, because that's likely where there's going to be mistakes. So under the age of 16, a common error is to use less than or equals to when you should have used less than, okay? And that will produce an error. But if you're doing proper tipping point testing, that should detect the error and you should be able to find it. So like in this one, when we do our 15-year-old one, that's fine, we get the discount. When we put in a 16-year-old one, oops, what happened there? They got a discount. They weren't supposed to get a discount because they're not under the age of 16. They've turned 16 now and sorry, you're an adult and discount days are over for you. 17 was fine because they paid the full adult fare. So something went wrong here. Okay, just like that seesaw, the face plant, that looks awful. Yeah, so what's happened here is in the code they've used this time, so again, it's Python code, but they've coded it a slightly different way. They thought, oh, this is much better. We can use less lines of code. And they've said if the age is less than or equal to 16, give them the discount. Otherwise, they're paying full fare. So that obviously should have been a less than 16, not a less than or equals to, and then everything would have been okay, all right? If they're less than 16, that's fine, they get the discount, but if they're equal, they don't. So if you just knocked out the equal sign from that code and just had it less than 16, that would all work fine. Okay, so As well as boundary conditions, you should also test your validation, of course. So put in someone is age 0, which is ridiculous, and your program should detect that and send out a message to the user not to put in silly values like that. Negative values, non-numeric values, like if they write the number 5 for 5 years old as FIVE, instead of putting a number in there, they should get an error message put out about that. If they totally forget the age on that form and leave it blank and click the button, or whatever's happening there, they don't bother entering it, just press enter, that should come up with validation code errors as well. And we've done plenty of validation code in our course so far. And then also go for the really unusual or unexpected values, like someone's 105 years old or 0.5 years old, and you're thinking, hang on, 0.5 years old, what's that all about? And how does someone live to be 105? Well, you know, people take babies on planes, and usually because that changes in air pressure, their ears are really sensitive, and that's why they cry so much on takeoff and landing and during the flight. Their babies are crying all the time. If you're sitting near someone with a baby on a flight, believe me, it's hell. I've done it. But you know, it's not the little baby's fault, man. Like, their ears are hurting like all hell from the pressure problems associated with flying. And here's a guy here. This is a 105-year-old person from Tibet, you know, like you think, wow, you know, how could they survive so long when it's so cold and freezing over there and things like that? But it must just be plenty of exercise and a healthy diet that makes all the difference. And that guy's still flying at 105 years old. So they're kind of your exception testing there to take sort of really different values than what you're expecting. Just make sure they work as well. Different values, but possible values. What else have we got left to do on this example? Oh yeah, then you do the Homer Simpson tests, as we call them. Things that incredibly stupid people would enter. So they type an age with letters like 15 instead of putting the number in. Nearly 7, the kid's nearly 7 years old. 12 to 13, because like they're 12 and a half years old. So maybe we'll just put 12-13 in there. 4.5. Type that in. So try and anticipate those errors. So Mark Kelly is a great teacher who's been doing software development for years. I think he's retired now, but yeah, I got this from one of his presentations. Actually, I love this idea. Oops, let's just go back. I love this idea of the Homer Simpson tests. And my students who have watched The Simpsons, as soon as you mention to them, hey, have you done your Homer Simpson tests? They know exactly what this means now. You know, ridiculous things like typing in the word 15 instead of putting the number in and things like that. Right, so we're on to, I think, maybe the second last or last section here, documenting the testing. So look, if you want to pause the video and take a break, just come back, that's fine. I just need a drink of water. All right, so this is where we put in all these values and try out all these things, but we need to actually capture that and prove to like clients, especially that, yeah, that money you paid for us, yeah, look, this was all spent on testing this section of the budget. And you can see we've tested the bejesus out of everything here. And, you know, it should be fine. You know, the program should be working. It's a quality product. So yeah, a lot of things are tested. They use these big crushing machines. I used to use these ones called Instrom machines, these German things. And yeah, when I had this job working in the military, we used to kind of crush and stretch all these components and things and see what their breaking point was. So yeah, they actually test those garbage bins which you get here in Australia with compression testing. And yeah, look, it's a bit of a boring job, but hey, it made me some money and got me some work experience. And you know, there was some little programming tasks on those machines, but yeah, when I first started, I had to do jobs like that, but then I got into the programming stuff, and then it was more fun. So yeah, whenever you start a job, like in engineering or in software engineering, yeah, don't expect to be doing all the fun stuff and big projects like you might have done in final year university. You'll be put on all the pleb jobs like this, the boring ones that people don't want to do, but you know, it's all good learning and all good for you in the long term. And testing tables is a bit of pleb job. People don't like doing it. Our students, it's not nearly as much fun as the testing they're doing on those tables there in the right hand corner. Yeah, and they do it without completing it properly, but you know, this is worth valuable points when you hand in assignments, so it needs to be done correctly. All right, so there should be a range of values like we said. Now they might not just be input values, they could be coming from an input file. So you also need to kind of put some improper data, incorrect data into input files and see what your program does with that. So we have an expected outcome and an actual outcome, and you should do all your Homer Simpson tests, leaving things blank, putting in ridiculous values and all of that sort of thing. And all of this gets documented in a thing called a testing table, which we're going to show you quite a few examples of now, so that you'll understand them and you'll be able to do them correctly on your next assignment. Okay, so this program here, let's look at some basic testing for this guy. This one, you put in a whole number between 1 and 99, and it's going to print out the square of the number, which is, you know, when you do, if the number's 5, the square is 5 times 5, and that's 25. So you do the number times itself. If you put in the number 3, its square is 3 times itself, 3 times 3 is 9. Hopefully remember all that sort of stuff from maths. So look, here's some of the tests you would do. Validation, the type of data, we want a number typed in. Now, often people will put units in as well with a number. So on your form, you usually have a separate kind of box to put the units in, or pick and click the units like we've done in, I think, the area perimeter program lesson. So yeah, 10 kilometers, yeah, if they do that, you need to just put out a message. Your program should be putting out a validation message saying, no, sorry, you need to enter a number. If they totally forget it and leave it blank, that's called an existence check, and you should know what sort of thing that is because we've done it in our course. Tell them they've got to enter a number. If they put in some good numbers like 10 and 15, work out 10 times 10 is 100 and 15 times 15 is 225. And then test the boundaries, because the boundaries are around 1 and 99, the beginning and the end, which is sometimes called range checking as well. So here we're testing right up the end, 99. Make sure that end number works. So 99 times 99 is, believe it or not, 9801, a big number there. And if they go beyond the boundary, so go just after the tipping point, just after the boundary here to 100, well, no, it'll tell them they've got to enter a number between 1 and 99. So notice it's a different error message to here. It's more specific, that it's not just the problem isn't just about entering a number. The problem is that the number isn't in the correct range. So you need to have that. Check out 0, which is just underneath that beginning tipping point at 1. And if they've put in 0, well, obviously that's not between 1 and 99. They should get the error message. And if they put in 1, that should be fine. This last guy here, 1, 1 times 1 is 1. And then the actual result about whether it passed or failed should be put in here. So, you know, 10 kilometers, actual result, you'd write in here like error message displayed, and that's a pass. Okay, because it did display the error message. Or you could write, if something went wrong and there wasn't an error message and it took that data into a number field and crashed the whole program, you'd put actual result, program crashed, and that's a fail. And then you need to go and fix that and redo that test, obviously, to make sure it's working. So that goes in those boxes. Now, we haven't shown you all of the tests there. They're the sort of main absolute necessary key tests that you must do. But you'd also need to test some Homer Simpson stuff, like check out if they try and put in a negative number. What happens if they put in like a decimal, like 2.5? What's your program going to do then? What if they put in a fraction? They want to know what 1/2 squared is. So they put 1/2 onto the screen to represent 1/2. And you do all of those sorts of things, the Homer Simpson test, typing in the word TWO instead of just typing the number 2. And you take screen prints of each of the results. So they won't fit in this table, but you usually kind of list them underneath the table in your Word document, screen prints to prove and show exactly what happened. So, with a Visual Basic program, let's do something Visual Basic specific or any object-oriented program. There's formula and function tests. So we might have formulas that are calculating things. We need to check out they're actually getting the correct answer. And functional testing is checking that all those buttons that you click on the form, the text boxes that they can put text into them, all of those objects on the form, it's testing objects to see that objects work. So formula testing is testing formulas you've written in the code. Functional testing is testing objects that you've got on your form. Just a word on formulas. A lot of students I have want to be games programmers and things like that. And yeah, they might have some great ideas for games. Some of them are using Adobe Illustrator and other things and making really cool characters that can be used in games. But you know, if you really want to get into it, you need to be good at maths, guys. Sorry to be the bearer of bad news, because there's a lot of physics in games. So there's just some physics formulas for you there. So look, I know you're all excited about playing computer games and you love to just be a games programmer, but realize, hey, you better be doing some mathematics for that. Just a bit of a off-the-cuff careers advice there. Okay, so formula testing. So we're going to test out some formulas in this. And these are the sort of things we need to look for. And again, we're going to have our kind of test table there with our results in it when we do it. Okay, so we'll leave you to read through those, get the PDF download and sort of read it in more detail. We'll just kind of skip through it here. So let's say simple interest formula. People would have done that in maths, that the interest you earn is the principal, how much you deposit, times the rate, times how long you leave it in there, in the bank account or the term deposit or whatever it is you're using. So interest is principal times rate times time. So we set up some test data here. We've got some different amounts of money. Geez, it'd be nice to have 150,000 to invest. Must be a programmer working in the greater San Francisco area in the US. Although living expenses are high there in San Francisco. I think it's second highest in the world or something, or in the US compared to New York City. You do get great coin being a programmer over there. Anyway, let's not get distracted. The interest rate, 0.12, that means 12%. That's 12% as a decimal. 0.5, you're only getting 0.5%. Oh no, sorry, it says 0.12%. That's horribly low. 0.5%, 1%. That's your interest rate. This is how long you're leaving it in there for. Someone's put that time in Homer Simpson style. That's not going to work. So those tests would be conducted and we make some table columns to record the results. So this is just the beginning of the test table. On the other right-hand side here, we need to add in more columns where we can record the results of the test. Just on interest and stuff and making money by investing. This book, it's a really old book. The Richest Man in Babylon. That's a great book to read, especially for young people, for when they first start earning money. Just about putting some money aside and having that money work for you can make such a difference. Great book to read sometime. So yeah, what we do is we add on our actual result and whether we passed or failed here on the result. Now, this is a bit confusing. When people put in numbers like 25, the Homer Simpson number, we get an error occur. That's what we expect. But people put that down. Students tend to write that as a fail. It's not a fail. That's exactly what should happen. If they don't put a number in, we should get an error. So validation error was expected and we actually got that validation error happening. So that's all good. That's actually a pass. It's not a fail. So just remember, data that is like fail data, because it's Homer Simpson type data that's not going to work, it's not actually a fail. Like if your validation traps that data and puts out the error message, that's a pass, okay? So just be aware of that. A lot of students seem to get confused and mess that up, we've noticed. Here's a volume calculation example for a landscape garden. We'll leave you to kind of look through it, but if you remember your maths, this guy's trying to mix up some cement and stuff to fill in an area, maybe in a courtyard or a path that he's making. And it's sort of length times width times depth, how thick the concrete has to be. And then we're going to display that out in our display.txt. So we've got a label out on our Visual Basic form to display that in. So we'd need to have some testing for that. So look, there's some test values, and see if you could like take that table and complete it and work out what the results would be. Check out the tests that might fail for some reasons. I don't know about a negative input width. That looks pretty strange. I don't think that's one's going to pass. Anyway, that's a little exercise for you. So if you want to pause the video, do that exercise and just check out, you've got an understanding of how to set up a test table for your test document. All right, let's talk about functional testing now. So that was all about formula testing. When you've got some formula you've put into your coding, you've got the values which people input, or they might have come in via a file that the program is reading in, and your program's going to crunch some numbers and get some answers, and you need to check they're right. That's formula testing. Functional testing, now remember we were talking about checking out the objects on the form. All right, so example is, if you've got a clear button on a form, you need to test that that clear button works. So back when we were doing our rectangle calculator for perimeter and area, that one there did have a clear button on it, which we've circled here, the clear button. So if they've just done a calculation here and it's on the screen and they want to clear it off to do another calculation, a different one, well, they click that clear button, and what should happen is that all those fields and drop-down lists and radio buttons, everything on the form should just be cleared out so that they can do a brand new one. So this is functional testing. On that form there are buttons like the calculate button, the clear button, the exit button. There's also like radio buttons you can click. There's drop-down lists here. All those objects which are on the form need to be tested. There's even a picture box where a picture appears. If the picture's not working on that, well, that's something which has failed a functional test. Okay, so that's all of the objects that you've dragged out and put onto your Visual Basic form. So a typical function testing table might look like this. So we have the date, what we were testing, how we tested it, include the test data that you used to put in, and what did you expect to happen, what actually happened. If there was actually a problem, like if it passed, failed the test, note down the action you took to correct the problem. So rather than just writing pass and fail and just having a fail and the fail isn't resolved, instead of that, you put this action taken to correct column on the far right hand side there and put it in. And remember, you always need those screenshots. Do a print screen and just capture that and put it in your testing document for each test that you do. So here's an example here. We're testing a date. So you put in July 4th. What we're testing, the OK button was clicked, and this one was actually a fail because the data saved, but we didn't get the processing coming back to the main menu again afterwards. So something went wrong there, so it needed some fixing, okay? And yeah, if you were a member of a testing team, you'd actually put down the name, your name in there, that you were the person that tested it. Okay, I think this is the last section. How long we've been going for here? Oh, half an hour, 30 minutes. All right, so let's try and wrap this up quickly. So in Melbourne, Australia here, we have this software development. It's called the U301. Yeah, programming folio, where you've got to design, build, and you do have to test them, guys. So many people, guys and girls, haven't been testing their programs properly, and they've been throwing away extra, points that they could have going towards their score. All right, so there needs to be testing. So let's just have a look. This is an assignment we gave our students after they'd done the horrible horoscopes learning exercise. We gave them this one, which was kind of using similar ideas, reading in some files, processing them, using substrings to pull out sections and then to assemble things together and stuff like that. So here's what happened with a good run of that program, and you need to test like the good runs where everything works properly. But you also need to do all these functional tests. Make sure that that drop-down list there, when they click that arrow, it's not just horse ran. There's like, 8 or 9 different options that should come up when they click that arrow. So make sure that's working. Make sure they can actually enter things into those text boxes, and the text boxes are supposed to be set up so that things are entered in uppercase letter and no lowercase are allowed. So you needed to test that that worked. Test your output label here. Check out that it is a label and it's not accidentally been made a text box. If it's a label, people can't type into it. If someone dragged out a text box that looks like the same sort of thing, if it's the wrong sort of object like a text box, they will be able to type into it, and that would have been a fail for that particular object on this form for this assignment. So you check out all of that. Then you need to do your validation testing. So like try and type a number in here for someone's first name. You should get a validation message pop up on the screen. So that sort of thing. Leave things blank, like don't bother picking an action phrase and try and create some fake news. It should come up with an error telling you need to pick one of those action phrases to use. And leave the name blank and see what happens then. You should get a validation error message pop up on your screen. So like this is how you would set it out. You'd have your input data. So for this good run here, yes, they put in the name in uppercase letters. That was all good. They'd actually made a selection. So we should get, some result come out that's okay, and it passed that test. You can, over here, we did get some result, which is shown with the print screen. So underneath the test table, you'd sort of have print screen 1, which you referred to in the test table here, and people could scroll down in your test document, find test screen 1 and go, oh yeah, okay, yep, that looks like it was all working okay. Because a picture for these sorts of things, especially with screen forms, is worth, 100 words in here. It's a lot easier to look at a picture than read all the words. So that's sort of how you'd set up the testing and do it for that. And it was disappointing on that assignment how many students didn't get that testing set up properly, didn't do it, or we had kind of blank ones down here where they had to kind of finish off figuring out all of the other tests that needed doing, and they didn't bother doing that. They thought, oh wow, I've done so many tests here and I've done so much stuff and I had to do all those screen prints. Oh, surely that's enough work. Well, it wasn't. It was only like about 4 out of 10, 40% of the work required. Here's an example for the area perimeter calculator program if you're doing functional tests, as we talked about. So you'd have some things like this in the test table, and we'll leave you to kind of read through that. You'd be checking out that your calculate button, your clear button, all those text boxes can get the data in them, all those sorts of things. And there's some more for the validation testing. So you'd need to put in some incorrect values, like leave one of the items blank, type in units with the numbers, and that shouldn't work because there's a separate pick and click drop down list for units in that program. So yeah, do all these tests, include your Homer Simpson tests, as many ridiculous things as you can think of to really try and break that program. Make sure it's unbreakable, make sure it's bulletproof, make sure when it gets to user acceptance and the users are checking it out that it's not going to fail, and it's going to be a happy project for everyone. So look, that's it for testing, but there is a bit more you have to do. We'll show you in a minute. Yeah, thanks to guys Mark Kelly, Troy Coggins, Simon Dorat. I did look at some of their presentations and ideas, and that sort of helped me out with this presentation. I have incorporated some of their material and ideas into here. Great job, guys. You rock. And yeah, look, if you've managed to stay awake and understood all this presentation, you're going places in information technology. Most people hate testing. They find it the most boring thing. They rush it, or they don't bother finishing it, or some people don't bother doing it at all. Don't be one of those persons. You've got to be like this guy, be the guy that just hangs in there and toughs it out. And one day maybe you might be wearing a white hat and be a programmer. Now, further reading, if you're doing the VC software development course here in Melbourne, Australia, the textbook that you guys have, this one right here, you need to read through chapter 9, and that has stuff on testing and evaluation. And they go into more detail here about things like syntax errors. That's another thing that can go wrong with your program. So you don't even get to run the thing, like it'll have all these messages from Visual Basic or whatever language you're using telling you you've coded something incorrect. So I remember in the string processing, our students, a lot of them were using, I think, plus signs instead of and signs and getting things wrong there. So that might come up as a syntax error. Logic errors, we've talked about them a bit in this presentation, like if you accidentally use greater than when it really should have been greater than or equal to, or maybe other way around, it should have been less than or equal to, but no, it should have been less than, but you use less than or equal to. So all those sorts of things, logic errors, which a program should test and find. Also runtime errors, like with some of the things we've done where we did subscripts and things like that and indexing. Yeah, if you've got a blank field on your form and you try and go in there and give me the thing from character position 2 in that text box, that'll crash because the whole thing's empty. It can't go and index something if nothing is there. Just like you can't go out to the street and drive your car if your car isn't there because someone stole the car last night or something, or your brother borrowed it without telling you. Yeah, so if you haven't got it there, you can't do actions on it. So that's another thing, you get runtime errors and stuff like that. So YouTube's just where we're storing our programming videos. And yeah, hey, with YouTube, thanks for the people that came on board as subscribers this week. We got quite a few new subscribers, and hopefully, you know, this course is going to be useful to you and the material in here. And if you're a teacher, yeah, you'll be able to share this with your students. So if you want to look at our full programming course, we've got a website there. So if you just go to the website, passieworldofict.com/programming, and there's a programming tab there to click on. Yeah, that'll show you our whole programming course. So we've got all of the lessons there, and today's one will be up there soon. It's not going to be there yet because we're just making the video. But yeah, look, like here's all our previous lessons. There's those couple of Python lessons we did do with the students if you want to look at a bit of Python. But mainly we're sticking to Visual Basic because that's the language we're using for teaching our students, because look, it's the easiest one to use and you can make the screen form interfaces so easily. And we haven't got time to mess around learning how to use the complexities of other languages in this course we're doing. Like, it's really crammed full of material that the students have to cover in just 3 lots of 10 weeks blocks. So it's just jam-packed. So we're just going for Visual Basic, and that's working out really well. So they're all lessons there. You can check those out. When you click on one, if this will just respond quickly with the web time. Yeah, like, you know, it's got sort of some stuff from the course here, what's in that particular lesson, shows you all of that. Come on, internet, come on, you can do it. It's got, you know, like the contents of everything that's in there in that lesson. This was like a really big lesson. The video you can watch that's for that lesson, step by step if you need it. If you want to fast track, I think this one has paid downloads because look, it's not free in this. There was so much in it, and I spent a lot of time putting that together. So this is actually a pay for one. But look, if you're a teacher wanting to use this for your class, it's Australian $5.30, less than $4 US. Like, that's, you know, 6 tiny little chicken McNuggets at McDonald's, I think, would cost you the same or a little bit more than that. So like, this is super cheap, and you can just securely do it with PayPal. Okay, just with a PayPal account. If you're a teacher, get the 30 computer license downloads one, click that, and you can get, you know, the presentation guide, the Word document with all the code, images you need for that project if there's images, and everything you need to do your programming in Visual Basic. Whoa, so that's it. That's all about testing. It takes a while to get used to it, but look, after you've done it a while, it just becomes automatic. You go, yeah, okay, I got to do the testing. And you know, all right, I better test some good things. I better test a few of those validations where things are going to go wrong, include some really way out Homer Simpson tests as well. I need to test both what's happening in my code, the logic in there. I need to look for tipping point conditions and make sure I test them. I need to check out any calculation formulas, make sure they're always getting the correct answer. And then I need to do functional testing on my Visual Basic program and check out that all of the drop-down lists, the radio buttons, the buttons you click on, clearing off of the form, all those sorts of things work as well. And that gets you functional testing. Then once you've got a few modules and they're linked together to make some little sort of app or system, got to do your integration testing. Last step is where you do that acceptance testing, where the client actually tries out the thing you've built for them and uses it, and hopefully they're absolutely delighted. They pay you the money, all of the money that's owed to you, give you a great review, give you a testimonial that you can use for future jobs, and it's all good. So look, enjoy testing your Visual Basic programs. And look, guys, it is boring, but you must test those programs. All right, so the next lesson should be on coding. It may not be out exactly next weekend. It might be a few days after the weekend because I've got a photo job, big photo job to do for the photography business next weekend. So yeah, it'll be a couple of days after the weekend, but we'll see you in the next lesson. And subscribe because we're putting out videos every week.